Well, hello. It's still in coronavirus lockdown. We've got plenty of radios, and I've got an echo on the monitor. One of the video monitors here just have the sound on a very, very low thing, so I just know the microphones are actually on. And we were messing with some of the video equipment, and that just got altered. Right, well, it's really funny this. I thought to myself, I'm going to do one more customer's repair, and then I'm going to do a video of one of our sets. And this repair, which I'm going to show you, is an Amstrad 900, not to be confused with the Amstrad 901. It doesn't have those 3 buttons for the Roger bleep and the public address and whatever. Channel 9, that's it. And I thought I'll just do one more of this customer's sets. Now he's a Richard, not me and not Mr. Chippy. We're all called Richard. This is really awkward. Bulk customer, trade customer Richard. He brings in radios by the crateful, and just before the lockdown he brought a whole pile over, so we're just wading through them. And I just thought to myself, I'm going to do one more customer set, and then I'm going to do our Amstrad 900, because not everybody has seen an Amstrad 900. And would you believe it, the next one out of Richard's batch is an Amstrad 900, so we'll do his rather than ours. So the good thing about the Amstrad 900 is that there aren't any fakes. They're all made in Japan. Where have my remotes gone? So whereas on the Amstrad 901 you've got the made in Japan original, which was £89, you've got the made in Hong Kong cheaper version, which was £69, £59, and then you've got the pirate copy, which sold at £29, also made in Hong Kong, and the only difference being between the genuine Hong Kong one and the fake one is that the printed circuit board on the genuine one is screen printed with the component locations. I've got a scrap board here, so look at that. All the component locations are screen printed. Compare that to this fake one, where you've got a bare printed circuit and no screen printing. So that's the fake one. Anyway, that doesn't apply to Amstrad 900s because they're all genuine, so everyone's a good un. So I've no doubt this will be no exception, and we will cover it. It's the same board as the 901, but it's always going to be genuine. Tell you what, you could get your nicotine fix off this radio. Wouldn't need your replacement patches if you sniff this for a few hours. You wouldn't believe where we get these glass pots from to put components in, and screws for each individual set so they don't get muddled up. These come, believe it or not, they're real glass. They come packaging with individual cheesecakes. It's either Aldi or Lidl. Lidl do the one with the serrated edge, and Aldi do the other, or whatever. And they're very useful. And Mr. Chippy introduced me to these products, and it seems an incredible way to do packaging of individual cheesecakes. But there you go. Very useful products afterwards. So onto the radio. The first thing we need to do is to do the VCO on most sets. And when they're this kind of age, 38, 39 years old, they can have been played with, although this looks immaculate. And the 900s don't seem to get played with. It's the 901s that get played with. So what we need to do is to locate capacitor 9, and capacitor 9 I will point out is, in this case, this green capacitor there, and it's the far pin. So I've got the front towards me with the channel selector switch, so that's the lower pin, that's the upper pin, and between there and earth. Now earth is not chassis on these sets because it's a floating ground, so what you need to do is to put your negative onto something like one of those screening cans. So we will find some ropey old jumper lead. And so the idea is to put your test meter onto that upper pin. That's not a good start. So we select channel 1 on the radio, and with the radio in receive, we adjust transformer 1 for 2 volts. Look at that, it's 2.1. It's never been fiddled with, it's never drifted. How's that for 38 years? So transformer 1, look, I can use either hand on this job. It seems to be clockwise to go down. I mean, in reality, you wouldn't need to adjust something which was 2.1, but this is just part of the demonstration. So where we are, 2.02. Then you set the radio into transmit. And it should be 2 volts, which it is. If it isn't, then you adjust the trimmer capacitor there, and I'm going to adjust it and upset it just as the demonstration. So we use the yellow tool for that. So I need to set it into transmit, which I've done, and we'll adjust that for 2 volts. I'll go out of transmit, returns to 2.02, which is what we set that to, into transmit 2. Okay. Then we just need to check that it's within lock on channel 40. So I'll put that back on. We're basically going to want that under 4 volts. So it's 3.4 on receive, it's 3.54 on transmit. The VCO is set. Now a lot of the time when you come up to anything with this Cybernet PT BM002F chassis, known as the Amstrad chassis, but it isn't an Amstrad chassis at all, it's a Cybernet chassis, used in some Harvard radios, and used in NATO 40, used in Harvard base stations, and Mustangs, and quite a few sets. Is that VCO is very important to be set. You end up with channels dropping off. You know, it won't work above channel 37. It won't work when it's cold. All those little tricks. It's always the VCO which is out of alignment. But that's one of the best ones I've seen for donkey's years. So that brings us to transmit, and hopefully. What I haven't got here, I haven't got picture monitors of every camera, so I have to remember what camera we've got on what input. Let's have a look what we have. Yeah, we'll do that one then. And try and keep my head out of the way. So the plan here, and when I just spotted it, it was doing really low power. That's my glass jars not stacking very well. So we've gone to the 3 watt range. What we're doing 220 milliwatts. Now that could be because the high-low power switch is out at the back. Well, that's better. So now we're doing 2.7 watts. So what we need to do is transformer 2, which is that one. Transformer 3, which is that one. Oh, by the way, we're doing this on channel 20. I just made a boo-boo there and started doing it on channel 40. Don't do that. So the first transformer, the second one, third one. These are very fine adjustments. Then we come to a more coarse adjustment. We're still at the same. There's no improvement being gained yet. It's doing about 3.7. The next coil is the one we'll just have to melt the wax in that one, which is L4 and then L8. That's interesting. The ballast resistor's been changed in this. That's not ideal. Wonder what's happened there. The kiss of death to these sets is where somebody's removed the ballast resistor. You can get another watt out of them for a few days until they die. I'm sure you can drive your car on full throttle for a few days till it dies as well. Not quite sure what they've done here. I'm getting 3.6 or something like that. I'm going to pause the video and we'll just see what the ballast resistor they put in is, because I think it should be 3.3 ohms. Something like that anyway. 3.6. So I'm not quite sure what this is about, but we've got 2.2 ohms and 2.2 ohms in series, which to my mind is 4.4. We'll just check it on this meter. Yep, 4.4 it is. That wasn't in screen, so we'll just do that again. Well, I know there should be 3.6. Sometimes you can safely put 3.3 in because 3.6 isn't a UK preferred value. So that can go in the vertical filing cabinet. And what have we got here? That's too low. That's 2.2. There we are, 3.3. So this is RS1442959, made in Barbados. Well, that's a different place than the usual type of component manufacturing. So put those back. We do have these handy on the bench because they kind of been stupidly omitted. So we'll just pop this in. So that's that fitted. They're actually specified as 3 watts. which is bizarre because it needs to be 7 in my opinion. So that's changed that, and we may end up with a little bit more of what he's entitled to power wise. So we'll just go through those again because it's now going to have affected this. So we'll go through that a few times till there's no improvement possible. So we've got that to about 3.7, and we will now move on to the deviation while we're on this same camera with this meter. Bear in mind this test equipment I'm using is selective on the frequencies. When I say it's 3.7 or 4 watts or whatever it is, it really is on the frequency we're transmitting. And if you use something like an SWR meter with a dummy loading to measure power, you may, if you tested this same set, see it read 6 watts, but that's including all the other rubbish which comes out. So deviation, these can suffer from over deviating and transmitting on 3 channels at once, which can be great fun for other users. So let's see what we've got. Okay. Well, it's supposed to be 2.5, it's 5. We'll turn that down to 2.2. And it's RV3. Wallow. A bit over the top still with a whistle test. Let's try it at that. Wallow. That's fine. That's deviation done. And we'll lose that camera. No, I'll tell you what we will do. We'll switch to camera 3. The power supply for camera 3 blew up the other day, so we've put a high band camcorder in instead of the DV cam plugged into the mixer. I don't think there'll be any difference. It's still 400 odd lines resolution. So I'm just waiting for a capacitor to turn up from RS in the hope of resurrecting the Sony DV cam power supply, which would be about £140 to replace, and I'm hoping we can fix it for £2.70. Alright, select that one. There we go. So when I key up, we should have 2779125, and it's 2779097. That's neither here nor there, but we'll just pop it onto frequency with the transformer number, I think it's L10, next to the reference crystal there, and I think it's upwards for higher frequency if I remember. Better than some of these sets which don't have variable reference crystals, such as the Unidens. There we go, we're on frequency. We'll lose that. So the next thing I want to do is to set up the meter for what it's worth. So we know the radio is just a shade under 4 watts and it's reading all the lights. So I wanted to read 4 of them. So it is, and I finally, yeah, it's RV1. So I'll key that up and show it the camera all in one. So we can adjust that 1, 2, 3, 4. That's where we want it. And if I switch to low power, it should be just 1 lighting, which is it is. Back to normal 4 watt power. 4. There we are. So that's that done. So we'll move over to the receiver. I wasn't expecting that repair though. That's weird, and why somebody made it slightly less powered by doing that, I'm not quite sure where they were thinking. But anyway, it's done now. So on the receiver, the first thing I want to do is to set the detector, and this is another thing that is susceptible to going out on these radios. I'm going to pause the video. We'll just put camera 2 onto the oscilloscope screen. Okay, so what have we got? Well, we're on channel 20. Now that's a bit quiet. I'm not sure what's happening there. Oh, it sounds like we've got a dirty volume control. So we'll sort that out here and now with the switch cleaner. I'll do the others at the same time. At least you can get into them to do that. So what we're looking for is maximum amplitude on the oscilloscope and adjusting T11 for that maximum. I'll just turn the bench light off in the hope that you can see the screen better. There we are, there's a bit of an improvement there. Now we'll turn the signal generator down, and we'll turn the squelch down and the RF gain up, the tone to full. So before being so rudely interrupted by a Duff volume control, which has now been replaced, if you can see that in the, well, we have, I had to revert to one off a scrap chassis. I didn't have anything new in stock, which was 50k with a switch. That's what's come off, and there's something seriously wrong with it. It's an A-type taper, so it's an audio one, so it's logarithmic in reality. So that can go in the vertical filing cabinet. So what we're going to now do is just to finish off the receiver. It's actually receiving very well indeed. You can, if you can hear that, it's, well, we're not going to get anything better than that, but I'm still going to go through it just for the video. We're going to start with transformer 5, and I'll switch the camera onto the Cynad meter for you. So the idea here is to have that needle moving towards the left like that as the signal gets better. So we'll try and work with it about 3 decibels like that. So we'll start with the T5. No change. T6. I just had the squelch come in then, so the preset was too high. So where were we? We were at transformer 6. Transformer 7. Just go back to what? To 5. And then move on to 8, 9, and 10. Just go through those early ones again. Oh, it's off our clock, that. That's 0.3 of a microvolt. .3, 0.2, 0.15, 0.1, 0.06. Okay. Now that's tuned. I'm just going to recheck that detector. Yep, that was spot on. And we'll set S9 to read 4 fairy lights. Isn't that a lovely phrase, fairy lights? I must use that next time I'm on 77's amateur. There we go, that's set to the 4th one. So now it's a matter of just setting the squelch. So as I've just roughly set it, because I had to, let's see how that is. Well, that's coming fine on minimum setting. So now we'll set the squelch to maximum. In fact, we can lose that camera. And see where that comes in. Oh no, that's far too weak. So it's RV5, which is the one there. So that's more coarse. It's a bit coarser than that. Let's try again then. So it's minimum. And that comes in fine. Turn it to maximum, and it's coming in about S8. It's the best compromise we can do on this, because if we have it any coarser, there's a danger of the receiver going into squelch with no signal, even on minimum. So that's the best compromise. The fake versions of the Amstrad 901 have atrocious squelch. It's really wishy-washy. Well, that's it then, isn't it? We're done. So yeah, we'll just pop it on. I'll put the front back on, and we'll pop it on the aero. Right, so all that remains is to put the cases on. Oh, it helps if we plug the mic in, doesn't it?
I do, yes.
That sounded like a marriage proposal, didn't it then? He said, I do. So there you have it, the Amstrad CB900. So all we're going to do is, he's had some work in the past where they've replaced some of the ICs. What can happen is people lose the power lead, which is easy to do on these, and then they put something on with no fuse, then they reverse polarity it, and then the protection diode fails because there's no fuse, and then it takes every IC out on the radio, and that's been done on this. But they've not been soldered. No, it's not the soldering, it's messy, and it just needs going over with isopropyl alcohol with a brush. So I'll do that off camera, and what we will do, we'll do an on-the-air test with this, and for the same bolt custom, we've got a Cybernet 3000 we'll do an on-the-air test with. So there's some forthcoming attractions. So there you are, the Amstrad 900, always genuine, never fake. Thank you for watching.